Hey everyone, this is Mohsin, and I'm going to be talking about my research presentation for Game 576. So, my topic was researching how to implement a particle system using OpenGL. And in this PowerPoint, I'll go through some of the basics of what I found and what needs to be implemented in order for getting a particle system to work, and then I'll present a quick demo of a basic particle system that I implemented in Visual Studio. So getting started here, the first thing that we would like to know, I guess, is what a particle system is actually used for in any sort of graphics situations. So compared to rigid models and structures that we've been implementing into our engines, particles can be used for simulation of non-rigid structures and anything that's amorphous and may have a not clearly defined boundary. So for example, fire or smoke, where you want to have something be amorphous and phase in and out at the edges, you would need particles for that that would constantly be phasing in and out of rendering. Beams of light, exhaust trails, anything that you would want to have be of a certain shape and be emitted from a certain position. And then for certain physical simulations and other instances where you're testing how a fluid mesh or shape might interact, these are where particles can also be used as well. So the first thing that you would need for a good particle system would be a lot of particles, and this is a very critical area of something that can be improved efficiently and something that would need to be done the correct way before even drawing a lot of particles. So, for example, in the demo that I'll show, it's a very simple demo, but I specify 100,000 particles to be drawn, which means that plenty of systems will obviously have many, many more. So the first thing that you'd want to make sure of is that you're reusing particles for efficient creation and deletion, and not always calling new or delete over and over again, because that can be very memory intensive and that can slow down the processor. This can be done in a couple of different ways. You could specify upfront how many properties or how many particles you want to have instanced, and then have a certain member variable for each particle specifying whether it should be drawn or not, or whether it should be rendered at all. Another way, obviously, that we've looked into before is having some sort of active and reserve pool, where rather than calling new and delete over and over again, you create a set number of reserve particles up front and then pull from that list and set it as active anytime you actually want one to be drawn. Another thing that's important to know is that particles would need to be spawned based on an initial position and velocity, and this is called a particle emitter, which is pretty much just a class or some sort of defining structure in code that specifies a source point of emission from which all particles spawn, and the key element of this is that you would need to just specify a general position and direction, and then have some sort of randomizing effect that would cause the actual direction to be varying from the specified initial position, based on whatever sort of algorithm that you would like, or how you would want the certain particle stream to look. But the randomization is what gives it the sort of random effect, and having it be having it look natural, especially in the case of fire, where you wouldn't want it to be very structured and predefined, and plenty of other examples as well. So next, you would give each particle individual properties. One of the most important ones, again based on which option you're choosing for creation and deletion, would be specifying the age of a particle over time and the lifespan, the maximum time for which it should exist. Again, you would want to randomize the direction of flight, and you would want to specify the position and velocity, as well as the size of these particles, so that when it's rendered, it's going in the correct direction. And another more important, a very important property would be the color and opacity, because, for example, if you're trying to render fire or smoke, it's gonna have a set color structure. So fire, for example, would go from bright yellow to orange to red, to very transparent red on the edges. And this would also need to be specified by the user in some sort of way to say that, for example, particles that are older might be further away at a certain point in time, and you would want to get it going to more of a reddish color, and you would also want to make it more transparent. And opacity is especially important in this regard because for amorphous structures, you would want to have a way for a particle system to be sort of transparent on the edges and look as if it's phasing in and out, and have that property if needed, because that's what would give it the more realistic effect. And this can all be specified in the code. This is just an example of a structure for a certain particle, and a particle buffer that could be specified and used on the GPU. So once you have all of these particles, you'd want to obviously draw and render them. There are a couple of major ways that I researched, and I found that this can be done. One is that you could have, for example, a VBO with a list of all the particles and all of their properties, and you would want to send all of that information to the GPU and have it render and draw them all. The downside of this is obviously that it's inefficient to manually render and draw a very large number of particles, and this could inevitably lead to slowdown and processor lag. Another method that I found is multiple instancing with shared data, and in this case you would just have a few smaller buffers with key information on particles, and this would be sent and reused for multiple particles very quickly on the GPU, and this would cause them to be rendered very quickly. So for example, you could have a single VBO buffer defining the shape. For a quad, for example, that might only be up to like 4 points, 4 vertices, and 2 triangles, and this could be defined for a single particle if you wanted all your particles to be the exact same shape. If they're all going to have the same approximate color and starting position, then you could specify that as a single value and randomize it based on the particle that you're indexing into on the vertex shader, for example, and then you could randomize it there and then draw it with the randomized values. But you could initially specify only the very small amount of data. So then obviously the upside of this is that you wouldn't need to constantly be sending over huge amounts of data. You could send over smaller amounts, and this would lead to performance gains when sending that data over from the CPU to the GPU. So yeah, as you can see, a lot of this is very similar to what we've already done in the game engine. So going forward, I would want to research more ways to bring this closer in line with our game engine and integrate it tighter. For example, you could specify the emitter as a rigid object and move that around similar to the Space Frigate or any of the rigid game object models that we've had. Another thing we could easily do is use other models for individual particles, and that could all be working together interleaved in the game engine. Another way of going forward and tighter integration would be interaction with rigid objects and animations. Obviously, implementing some method of collision detection, especially with particles, would be somewhat daunting, but that would definitely provide an extra layer of realism to how the particles are being rendered. And then obviously adding more nuanced particle physics. In the demo that I'll show, I have a very basic function for just specifying an amount of gravity to add, but obviously various particle physics can be implemented, and this would give you the ability to have a wide variety of effects on amorphous structures and fluid meshes and such. So yeah, that's some of the basics. Hopefully I condensed some of those points in a succinct manner, but thanks for listening. Now I'll jump into the demo here. So I used a previous single file application from the first game engine class where we're initializing just some of the window and projection matrix information, and then in the startup method I specify the vertex shader code and the fragment shader, and I create the OpenGL shader program and bind the VAO all right here. This is because I ran into some trouble when trying to separate things out into classes and structures, and I ran into just some problems with the particle system not showing up, so I at least wanted to have something basic working for this presentation. Here in the render, I'll specify the color of the window, just a basic view matrix, and I'll pass in the uniforms for such as the time, the view matrix, the projection matrix, and then here I'll draw the points as GL points, and then I'll draw it max particles number of times. So 100,000 is the number that I specified up here. Now here in the vertex shader, I'm passing out as a parameter the smooth color. I have the view and projection matrix and the times coming in as uniforms. This is where acceleration and acceleration due to gravity can be specified. The rate of emission and the life of the particle is specified here. So a lot of the properties for the particles are actually just a part of the vertex shader itself. A very natural next step from here would be to take out some of these properties and separate them into a particle class. So here a random direction is given to the particle based on the starting point, and then here in the main function we would essentially specify the position, get some of the properties such as the direction, the time, the lifespan of the particle. Here the direction again is given as a random one, and then the color of the particle is mixed between red and yellow, and then the position is specified, and then the fragment shader is very standard. So in essence, then just building this and running this is what we would get. So we have a source emitter point right here. Particles happen to be, they blend from yellow to red the longer that a particle, the longer the age of the particle, and you can see that we have the ability to essentially spawn multiple particles in this sense, and they're generally very random in terms of their specific direction and position at any given time. And yeah, so for example, in this case, this could easily be extended to look like the exhaust trail of a rocket or something for that matter. But yeah, at least I just wanted to get some sort of demo working of a particle system. Obviously, I don't really have moving around like the camera or anything working yet. There's a lot more that I would want to go in depth, but I kind of just ran out of time. But yeah, this is my presentation of a basic particle system in OpenGL, and I hope you enjoyed it.